Whew. All right. Well, I will begin with a word of prayer today. So here we go. Dear Father, we thank you for this day. Again, I thank you for this class. Just ask you just help us use this time wisely, that we would glorify you what we do, and we just resolve any questions that remain for the test tomorrow, Lord. And in my prayer, Lord Jesus. Amen. Okay, guys. So, as I was telling, some of you have come in after I said these things, but so I'm covering another colleague of mine's class from the 12 o'clock slot, Monday, Wednesday, Friday. So like my office hours that were on Monday and Friday, those are gone now. They may come back if he comes back. He should probably come back. But for the time being, I'm teaching that class, and then so just be aware of that. And so the grader tired, so she did not grade mission 3 carefully at all, really. So I just graded it. And my way of grading is if you did it, you get a check mark, which means you got full credit. So that's what the check mark means. The same goes for Math Battle 1. I do try to grade those more carefully, generally speaking, but this particular time period, I'm out of time, so I got to get them back to you. I'm also behind in the solution for Mission 3 at the moment, but I'm working on it, so hopefully by the end of the day, I should have the rest of the problems posted. That said, if there's anything in particular you guys want to look at right now, we do have some time, so, ask away. Yep.
Can we go over the logic of 109?
109. Oh, by the way, the one I changed from cosine of 3x, there was no need. There was no need to change that one, actually. Somebody pointed out, like that thing I thought was a typo. You could have just done like 139D. You could have done this. $139. Yeah, x goes to pi of tangent cubed x cosine of 3x over, I'll write this systematically, x minus pi, that's what's given, right? And the question is f prime of a for what f, right? So the stupid thing I should have seen is that it's not a typo, it just requires, yes. That's the first moderately skillful thing I've done today. That's probably a little bit much. All right, so look, the thing is, what is tangent of 0? Yeah, 0. That's not interesting. What is tangent of pi? Tangent of pi is sine of pi over cosine pi, which is also known as 0 over minus 1, also known as 0. So the thing is, we could have just written minus tangent cubed of 0 cosine of 3 times 0. That would be true. And then you can just go, oh, this is f prime of pi for f of x equals to just tangent cubed of x times the cosine of 3x. So I'm sorry. Sometimes I do this. Like yesterday I was like, oh, I want to make it about tangent squared. Tangent squared is, it's secant squared theta, it's secant squared minus 1. I mean, this is true. You don't need that for this problem. So my apologies for overcomplicating that one yesterday, or whatever day it was I did that. I'll have to check the YouTube. Now you asked me about a problem before I did this. What was it, 109? Oh yeah, this one is tricky. This one is tricky. So you have f is continuous on the closed interval from 1 to 5. And you have that f of x equals to 6 only has x equals to 1 and x equals to 4 as solutions. Where? oh, just anywhere. All right. And then it says if f of 2 is equal to 8, then explain why f of 3 is greater than 6. So if you've read my solution, I used something called contradiction to solve this. All right? So did you have a question about the solution, or you just want me to like walk through the solution and talk it out? Is that how I reach that proof? Oh, personally, I write down a slightly incorrect proof, and then I go, ah, and then I start again, and then I come to that proof. That's the truth. Another truth is I draw a picture to try to understand what's going on. So like the picture is not a proof, but it's a good step in the right direction. So like, you know, this is y equals to 6, right? And we're given that it's continuous on 1 to 5. So I should think about 1 to 5, you know? And I also know that it has solutions, x equals 1 and 4, right? So like here and here are 2 points where the graph crosses the value of 6, right? And then I'm also told that f of 2 is equal to 8, so that puts a point on the graph like up here, right? And then I know it's continuous on 1 to 5. So I know that if I draw the graph, it could do like this, right? Like that would be okay. That would be consistent with the data which is given, right? However, and so like where's f of 3? You know, 3, 1, 2, you know, 3 is here somewhere. That's 4, right? So 3 is like here. So you see, in my hypothetical correct example, this would be like f of 3, and of course it has to be greater than 6, right? So that sets the stage. Okay, I realize, all right, well then I probably can use a proof by contradiction to come up with like an ironclad argument. So the proof by contradiction says, okay, well suppose it's not the case, right? So to suppose f of 3 is less than 6 or equal to 6 puts it down here, right? Of course, if f of 3 is equal to 6, game over. We've already contradicted the data because we're told at the start of the problem f of x is only equal to 6 for 1 and 4. So I cannot have f of 3 equals to 6. That's out of the running. So suppose everything else being said in the problem statement's already been said. All right, f of 3 is less than 6, right? Then like my guide here is if that's the case, then it's got to do like this, right? Oh, my bad. We're stuck with this. We have to go up through that point, right? So it's got to turn around somehow and come back down through there. And then it would come back up. And I guess, I mean, it could end like that, fine. But the point is, you got this right here is a problem. Because that is an additional solution to f of x equals to 6, which is forbidden by the problem. So then my logic is I should try to use the intermediate value theorem to detect the existence of this crossing. So the intermediate value theorem I'm going to apply between the data that I have, right, which is at 2, right? I know something about 2, and I know something about 4, right? So maybe I can apply the intermediate value theorem on 2 to 4, right? So notice f continuous on 2 to 4 because 2 to the 4 is a subset of 1 to 5, right? So like that's a theorem about continuous functions. If you got continuous on a superset, it's continuous on any subset. That's kind of, it's just an obvious thing. We didn't even state it as a theorem. It's just obvious. All right, so f is continuous on 2 to 4. And what else do we know? Well, f of 2 is equal to, what is it? It was given to be equal to 8, right? That is greater than 6, which is greater than f of 3. by assumption, right? Thus, 6 is an intermediate value. For f on 2 to 4, so there exists c in somewhere in 2 to 4 such that what? Such that f of c is equal to 6. But if c is between 2 and 4, right, it cannot be what? Oh, I shouldn't have done 4. I should have done, what should I have done? Should I have done 4? This is dumb. 4 is causing me trouble. I shouldn't have done 4. Did I need to use 4? I didn't use 4. What should I have used instead of 4 here in this argument? My bad. I mean, 4 is troublesome. 4 is where it goes through 6. We're trying to like separate that issue from the current issue. So instead of using 4, I should have done the argument for 3, I think. Yeah. Let's see here. So let's put 3 here, 2 to 3, right? So f of 2 is given to be 8. We're assuming that f of 3 is less than 6. Therefore, 6 is an intermediate value between f of 2 and f of 3, which means that there's a number by the continuity of f between 2 and 3 such that f of c is equal to 6. But that would mean that c is a number somewhere between 2 and 3, which is, so that says that, but c is not equal to 1 or 4, right? Because of the context here, which is a contradiction. And this is just my symbol for contradiction. So if you assume something, right, and you go through logical arguments that come to an absurdity, then proof by contradiction says that your assumption is wrong. So if my assumption that f of 3 is less than 6 is wrong, that only leaves us one other possibility. Since we're given that f of 3 exists, because we're told f is continuous on 1 to 5 to start with, so the value of f of 3 is given to exist. It's in the domain by assumption. That's not an issue of consideration. So the only other possibility is either f of 3 equals to 6, which we already talked about being also being absurd. That violates the problem statement. Or what? F of 3 being greater than 6. And that's why f of 3 has to be greater than 6. This is called proof by contradiction. This problem is from the dark heart of Dr. Sprano. This is Dr. Sprano's problem. I don't think like this. This is a great problem. Yeah.
On a scale of 1 to 10, how much easier would the test be than this one? All the missions.
Oh, the test is very easy for every problem that you understand. But every problem that you don't understand, the test is very hard. That much we can say. So, I don't know. You can look at old tests to get a sense of it. I'm not going to ask 10 ones like this, right? I can ask one like this. But, I wouldn't make 95% of the test proof by contradiction, because this is the homework problem that has come up in. This is the lone isolated example that we have had of proof by contradiction, so far as I can remember. Right? So, yeah. 123. Ah, yes. That one I can do. So, problem 123. And this reminds me, so I know some of you know things from before because, you had like calculus in high school and stuff, and it is fairly easy to remember the things that come after test 1. And the things that come before test 1 are often forgotten because we don't like them. And so you'd rather do it the way later in the course. But the thing is, this is test 1, and you got to do it the way we're doing it here. We don't know those things yet. So we do need to actually prove by the definition of the derivative. Now you got two choices. You can either go with the limit as h goes to 0, or you can go with the limit as x goes to a. What do you guys want me to try? I'm going to try x goes to a for this one. So f prime of a, the limit as x goes to a of, so I got myself what? I got 1 over x minus a times the difference of f of x and f of a, which is x over 3x minus 6 minus a over 3a minus 6. All right? Now, while I'm fixing the camera, why don't you guys go ahead and factor out a third? We can factor a third out of this and make our life a little bit easier. Just put the third out front. So that way we won't have to fight with the third for the rest of the calculation. Just leave the third out front. See, because it's 3 times x minus 2, and it's 3 times a minus 3. 2, rather. My bad. So 1/3 limit as x goes to a of 1 over x minus a, and then we got ourselves an x over x minus 2 minus a over a minus 2. Yeah. And so, I mean, not a big deal. If you didn't do this step, you could still get through it. I just think it makes it easier to see what we're doing by doing that, okay? And then my next move is simply going to be to make a common denominator. Did you guys see that? So there's nothing in common with these denominators, so you just cross multiply, right? And that's going to give you a 1/3 limit as x goes to a of 1 over x minus a. And so I've got an x times a minus 2 minus a times x minus 2, all divided by x minus 2 times a minus 2. Notice that the product of x and a and the product of a and x, they cancel. They reduce, right? So this term essentially cancels with that term. And what we're left with then is 1/3 limit as x goes to a, 1 over x minus a. All right, so that's going to give me a minus 2x plus 2a. Right? And rather than writing that, can you guys tell me a better way to write that for our purposes? Factor the minus 2 out, right? If we factor a minus 2 out, we can write this as just minus 2 times x minus a. So then, gleefully, the x minus a's cancel, right? Like that and that. We can pull the minus 2 out, and we can plug the limit point in. What do we got? We've got ourselves a minus 2 over 3, and then 1 over a minus 2 times, well, a minus 2, which, of course, we could rewrite as minus 2 over 3 times the quantity a minus 2 squared, like that. Does that make sense? I mean, so I would say, generically speaking, if you're dealing with a rational function, I mean, you can choose the x limit or the h limit. Either might work. But usually it's just going to be like making a common denominator. That's going to resolve the limit for these ones. Does that make sense? No? Other questions? Number 18?
118.
Oh, 118. So this one here, you got f of x is 3x cubed minus 2x. I probably meant to put a square there, but it doesn't really matter. Plus x plus 22. And you're asked to show that there exists a c in the real such that f of c is equal to 0. So show there exists a real solution to f of x equals to 0. That's the problem that's asked here, basically. So this is just a straight intermediate value question. All you got to do is find, a value where the function is positive and a value where the function is negative. Then the intermediate value theorem says 0 is an intermediate value, therefore 0 is attained by some input between those.
So just plugging a 0?
Sure, we could do that. So I guess to start with, we notice f is continuous. Where is it continuous? Everywhere, okay? It's continuous on R. It's a polynomial. So we can apply the intermediate value theorem wherever we like. You said look at 0. I like that. F of 0 is 22. All right, great. That's positive. Now you got to find an input for f which makes it negative. Any ideas? -3? Sure. Let's see here. 3 times -3 cubed minus 2 times -3 minus 3 plus 22. Let's see how that works out. So you got yourself a that's, hey, I like it. That's -81, isn't it? And plus 6 minus, plus 6 plus 19, which is like, 25. Yeah, it's negative 25, 61, 50. I'm just trying to do it. Maybe it's minus 55, maybe 56. I don't know. 56, maybe. Yeah. Anyway, the point is that is less than 0. This is greater than 0. Hence, f of 0 is greater than 0 is greater than f of -3. Thus, by intermediate value theorem, there exists C somewhere between 0 and 3, such that f of C is equal to 0, which is what we were asked to show. Now the problem didn't tell you to plug in -3, and it didn't tell me to plug in 0. So that's up to you guys. You got to have the creative wherewithal to pick two numbers that it changes from positive to negative. Now this is not terribly surprising, because you should know that if you're talking about a cubic polynomial, right? If it's positive coefficient, it looks something kind of sort of like that, right? So it has to be positive somewhere and negative somewhere else. And if you plug in a sufficiently negative number, it's going to be negative, right? Like in my solution, when you read it, you'll see that I was much more greedy. I just used -10. Because like -10 is going to make this 1,000. And -1,000 is going to dwarf whatever else happens in the rest of the formula. I don't need to think about it. It's negative, But if you're actually trying to find a good approximation to the solution, 3 is a much better answer, because then somewhere between 0 and 3 there's a solution. So you could, like, if you wanted to, you could zoom in and try to find it with that method we talked about. Yep. Yeah. Yep. There's the ingredients for a full credit intermediate value question is noting that the function's continuous, observing the values of the function that are above and below the desired intermediate value, and then claiming the intermediate value theorem. It's like a coupon. You got to redeem it. Right? We don't do coupons anymore. I mean, I don't. Fair enough. But yeah. Wait a minute. I'm not sure how I was agreeing to. Maybe you have the same question. Arm wrestle. No? 104? I'm always trying to get students to arm wrestle. They never do. Let's see here. 104. No, yowzers. Well, this one, I'm going to erase my work for the other one, if that's okay with you guys. I'm going to try to go fast through this one. Basically, the point here is that the limit which is given, we can reduce because we know the limit of sign of an argument over the same argument limits to 1 as that argument goes to 0. We worked this out in class. It's a known limit, but it's not obvious. So like, you know, fun fact we should keep in mind as we work this problem, which is that the limit as theta goes to 0 of sine theta over theta is equal to 1. So we work that out, and that's kind of relevant here. This problem 104, you're trying to show it's continuous at 0, right? So you have f of x is tangent of mx over x for x less than 0, and it's 3x plus m squared for x greater than or equal to 0, right? And the question is to find a value for m which makes it continuous at 0. There is a very lazy answer which makes it sort of obviously continuous. If you put m equals to 0, if you choose the constant m to be 0, that makes the top case just the 0 function, because like tangent of 0 is just 0. So that just becomes the constant function 0. So like if m is equal to 0, then you can work it out. But there's really not much work to do except to write stuff down. See, because 3x plus 0 is 3x. Yeah. So like graphically what you're looking at is just this, right? Which is continuous if m equals to 0. So that would be one answer to the problem that I should have outlawed, because that's really not what I wanted. So suppose m is not equal to 0. Let's look for that solution. Let's assume m is not equal to 0. Then notice that the limit as x goes to 0 from the right of f of x is equal to what? The limit as x goes to 0 from the right of 3x plus m squared. But that limit just gives us m squared, right? What is it?
Oh, I just don't understand how, like, it's over 0 still exists.
This one?
Could it be over 0?
Yes, but tangent also goes to 0, so it's indeterminate. We'll work it out. So from the right, we get m squared because of that case. But from the left, you're right, it's concerning, right? It looks like maybe something doesn't work out there. But how does it go? Well, from the left, we have tangent mx. And I'm going to write tangent mx as what it is, which is sine of mx over x times cosine mx, right? See, that doesn't necessarily blow up because it's got a 0 in the numerator and the denominator, so they could maybe cancel each other out somehow. So the thing that's a little bit tricky about this is I have to use my imagination, see, because what I need is something like this. So I got like sine of mx over mx times the limit as x goes to 0 of, well, let me not do this yet, times m over cosine mx. Now the reason I did that is because what I know about is the limit as sine theta over theta goes to 0. I know that limit's 1. So I have to have the argument of the sine match the thing I'm dividing by. Okay? I can make a substitution then. I can say, oh, okay, well, this is really the limit, as x goes to 0 from the left of sine mx over mx times the limit as x goes to 0 from the left of m over cosine mx. This, we can just make the substitution theta equals to mx, okay? And with that substitution, theta goes to 0. As if x goes to 0, theta goes to 0. So anyway, that is just 1 by the limit we already know. That's 1. But this is what? Plug in 0, you get m over cosine of 0, right? Which is So that's 1. This is m. So it works out to m. So the right limit is m squared. The left limit is m. For continuity, what do we need? I thought I had a 2. Where am I? I'm thinking of a different problem. Oh, no, I copied it down wrong, guys. What's in the problem? What have I failed to transcribe? Yeah, I put a 2 on that m squared just to mess with you guys, didn't I? Apparently I was messing with me. So that's a 2 there, and there, and there. That's it. So if we want the left and the right limits to be equal, which we need for the limit to exist, we need that 2m squared is equal to m, right? By the way, 2m squared is also equal to f of 0, isn't it? Notice that's the case that it's included in. So we need f of 0 to be equal to the limit as x goes to 0 of f of x in order for continuity to hold, right? Continuity means that the limit as x goes to a of f of x is equal to f of a. That's continuity at a. So for us, in this example, from this calculations, we see that we need 2m squared equals to m. So that says what? M is equal to what? I assumed m is not equal to 0, so we can divide by it. So we get 2m equals to 1. So lo and behold, m is a half. Anyway, that's at least one solution of it. So I think a half and 0 are the only solutions to this problem, truth be told. Okay, so anyway, does that make sense? I mean, it's a little bit tricky because there's an indeterminate limit to deal with. You know, that's what makes that one a little bit sneaky. Other questions? What was your, yeah? 125. Where did I put it? Oh, sure. This one, I think the h limit's the way to go for this one, because, all right, with a polynomial, if you use the h formalism, you just have the problem of basically like foiling out your f of a plus h. If you use the x formalism, you have the problem of factoring the polynomial. We could factor the polynomial, but the thing is, we'd have to factor basically the part that corresponds to like the 5x squared and the part that's 17x kind of separately, and that would be kind of a drag. So it's easier to do it with the h formalism here. So this is problem 125. And so here we have f of f prime of minus 1. That would be, I'm going to write out symbolically just to start with, limit as h goes to 0 of f of minus 1 plus h minus f of minus 1 divided by h, right? Which is the limit as h goes to 0. Now my f of x is a bit ugly. It's 5 times minus 1 plus h squared plus 17 times minus 1 plus h. And then you got your plus 1, all right? Then I'm supposed to subtract. And so just pro tip. Pro tip for you here. Parentheses. Write parentheses when you're actually putting the formula here, because it will help you not make the mistake that you're going to make otherwise. I'm putting f of minus 1 inside the parentheses. What is f of minus 1? I guess I probably should have written the formula for you guys somewhere. What was f of x? It was 5x squared plus 17x plus 1, I believe. I better double check that. Yes. So if I plug minus 1 into that, I get 5 minus 17 plus 1. All right? Putting that in the parentheses hopefully safeguards me from not distributing that minus to everywhere it needs to go. All right? Which is the most popular mistake students make on this problem if they're actually trying to do it. Let's see here. So anyway, these ones, they be canceling. And this 17 and that minus 1 cancels, and this 5 cancels. Anyway, let me actually write it out. So we got 5 times 1 minus 2h plus h squared minus 17 plus 17h minus 5 plus 17 divided by h. So all I did was multiply out the 1 minus 1 plus h squared, and I distributed the 17 as well. All right? Now, as I was saying a second ago, the 17s cancel, right? And that 5 is going to cancel with this 1 over here, right? And what that's going to give me then, limit as h goes to 0 of minus 10h plus 5h squared plus 17h divided by h, which limit is h goes to 0 of minus 10 plus 5h plus 17, which gives us like, you know, minus 10 plus 17. So apparently the answer is 7. Yeah. So is there a particular place you're hung up? I mean, like, it's just...
Couldn't figure out how to start it for some reason.
Oh, okay. We've done a lot with the A and not too much with the numbers, but it's the same thing. It's just, I sometimes think it makes it easier to do with an A rather than a number. I don't know why. For me, sometimes it's easier without the number, with just like a variable. It shouldn't really make a difference, honestly, but general point of order, if you get stuck, right? If you get stuck as you're calculating the derivative from the definition, if you're using the x formalism, maybe shift gears and try the h instead. You know, I've seen, like, I saw one person get stuck on a quiz, like they couldn't see on the last quiz how to factor that thing because it had the x squared and the 3x, you know. That tripped up some of you guys, but I had one person who had that happen, and then instead of just kind of giving up or making some like nonsense algebra which wasn't true, I saw some of that, they instead just went over and tried the h formalism instead, and then for whatever reason the algebra and the h way of thinking just fell into their lap and it made sense. So, I mean, yeah. Anyway, I'll see you guys tomorrow. I hope you do well. Do your best, that's all you can do.